All right, thank you. So, do you have any questions from the audience? Okay, I will kick it off. In the overhead that you showed, roughly what proportion of the computational overhead is kind of due to the homomorphic encryption versus other parts of the computation?
Yes. Can you hear me okay?
Yes.
Okay. Hi. So for the users, a lot of the overhead is due to the ciphertexts, which is good because the ciphertexts are reduced. In terms of the aggregator, this is also a pretty good portion of the overhead because they have to take like a billion ciphertexts and add them up. The aggregator also has some additional costs, like for instance, verifying the zero knowledge proofs, which is right now a pretty large bottleneck just because of the number of proofs and kind of the large ciphertext that these proofs depend on. But at least for the users, basically, like any factor we can cut out in the ciphertext size will kind of directly reduce their total overhead by that amount, at least in terms of like bandwidth. Yeah, and then the computational costs for users are pretty limited. Yeah.
Okay, great. We have a question from on Zoom from the Q&A. That's from an anonymous attendee. If they want to ask themselves, please feel free to raise your hand, but I will ask it in the meanwhile. So they say, good work. I noticed that in the paper, the key pair is reused across rounds, but in the Honeycrisp paper for each round, a new committee needs to be elected and a new key pair needs to be generated. Is VSR the only modification needed to make this reusing work and secure?
Yes, basically, yes. So we introduced this this VSR to cover shares between committees. So in this work, we have a securely in the first place, and this basically saves us on the key generation cost. So it makes the costs for the committee a little bit lower. I didn't mention this in the talk, but the committee is a small group of elected devices which performs the decryption. So we did this, yeah, to reduce those costs, and that is, yeah, that's the only modification. Thank you.
And actually, Natalie, before you ask, so Ido, some people notice that your audio is cutting out a little bit intermittently. So I don't know if that's something that you can fix, but maybe while Natalie's asking a question from Slack, you can see if there is. But
I'll ask slowly. So this question asks, in the case of Mycelium, there is an assumption that the aggregator has access to a data center. Do you expect the data center to be dedicated to Mycelium?
All right, hopefully, I'm just gonna speak a little bit closer to the microphone and slower. And I think that given the current costs, at least having some portion of a data center dedicated to it would make sense. Yeah, we haven't done any sort of in-depth study about that, but I think that makes sense. Yeah.
And we have a question from Edward Tremel.
Hi, yeah, so this is very interesting. I've looked at a problem like this before, and it's pretty difficult to solve with the need to have both privacy and correct data. And I wondered if you, how certain you were of the restriction that devices can't ever communicate directly with each other. They have to go through the aggregator, which exposes them to all the privacy problems, because it seems like you could have a much more efficient mixnet, for example, if these devices, which are phones that can connect to the internet that are publicly routable, could just communicate with each other to mix their data.
Yeah, so I mean, so that is a good point. In this paper, we you're right, we assume that that is not possible. And I think assuming that would introduce additional vectors of security and privacy issues. So in this case, we make the assumption that everything has to go through the aggregator, and we do show a way to actually achieve everything we want in that setting. I agree, it would be really interesting to kind of take a look at some sort of hybrid setting and see if you could maybe, you know, improve costs or do something. I'm really interested in figuring out how you can maybe create local communities of communication. But in this setting, this helps us analyze properties and make sure that there's kind of there's no possible leakage. But yeah, that's a good point and a good question.
Okay, thanks.
I mean, yeah, let me know if you have ideas about that.
Okay, I have another question. So so when you talked about the overheads to end user devices, when do those overheads occur? Are those sort of per query or per interaction between devices or periodically, or sort of when do they occur on the end user devices?
Yeah, so we designed this to be a sort of long query. This is because we kind of want all devices to be able to get online at some point. This is not going to design to be fast queries that are being asked all the time. This could be something that takes place over the period of 24-hour period or something, is kind of how we have these imagined. So this might be something that is going to take place over a day period. It's not going to be like all flooding at once. Yeah.
Right. So that means that the 15 minutes, let's say, of computation is not something that's, say, happening every time two phones are near each other or whatever is happening, let's say, at night when everybody's phones are plugged in or something like that.
Exactly, correct. So every once in a while, you know, whoever is issuing some query is going to say, you know, I have this important query, and this could happen at any point during the day. Yeah, maybe when your phone is plugged in, you could send up whatever is necessary. Yeah. Good question.
Okay, I think we have time for at least one more, which I will take up if nobody else has questions. Okay, lucky me. So the only sort of limitation that you showed was this one query of the batch of queries that you kind of collected from the medical research that you were not able to answer. You said kind of due to the particular FHE scheme that you, or the FHE encoding rather, that you used. How difficult would it be to adapt if you cared about answering that particular query? Is this a limitation that you can kind of have either or? And if so, how difficult is it to adapt, or what would the overhead look like potentially to, you know, construct a system that could answer all these questions?
Yeah, so this is definitely something that we could do. It's kind of an artifact of certain things to do with our prototype. So we use this BGV encryption scheme, which actually can support, essentially this is a limitation of how many multiplications we can do in the FHE scheme. And this scheme actually supports way more multiplications than what we actually, an artifact of how we implement our distributed decryption. And so there could be ways to do this. And in fact, it wouldn't really increase overhead, would just require us to implement things, which we didn't do. I mean, it would increase overhead in that this query requires more rounds, like requires more depth in the graph. So I would send something to my neighbors, who'd send something to the neighbors. So it would just basically create a longer round. So like a couple of days as opposed to one day, but it wouldn't increase the amount of communication. Yeah.
Okay, and I think even though we're just slightly over time, there's one more question from Slack that I think we probably can try and surface.
So this question asks, is data decryption by anyone in the network the or a primary threat for Mycelium or other threats that you've accounted for?
Yeah, thank you for your question. So there are a few different vectors that we're looking at. And data decryption is maybe the one that is most solid because we have these strong encryption schemes that security researchers have been working on. But there are basically, the vectors are kind of the aggregator themselves doing something in the setup or not including people's data, which we protect against, or trying to drop messages, which we protect against, or colluding with various devices or the devices themselves, trying to do malicious things against devices trying to mess up the computation to some extent. So inputting garbage things to try to offset the total results. So yeah, we have to protect against all these different kinds of threats, which is a difficult balancing act. So thank you.
Okay, thank you, Ido. Thank you to the other speakers as well. Thank you, people, for asking questions. And I should mention, I forgot to introduce at the beginning of the session, Natalie, who was co-chairing the session. And because many of the questions were on Slack, she ended up, as you were all saying, doing a majority of the work. So thank you, Natalie. And with that, I think we can adjourn for the break. And hopefully we will see everyone in the next session on learning.
Okay, so yeah, first of all, apology. I forgot to introduce the author. Okay, so I'm doing that now. So Ido Roth is a PhD student at the University of Pennsylvania. So he is currently on the job market looking for industry jobs. So if you have positions, please go contact Ido. And another author in the paper, Karan. Karan is a second-year PhD student who is looking for research internships this summer. I guess when they say this summer, I mean next summer. So if you have a position looking for interns, reach out to Karan. All right, with that, okay, so let's start the Q&A. And we have one question from the audience. Tianxiang, feel free to enable your camera. Okay, now we can see you. Go for it.
Hello, I'm a PhD student from Hong Kong University. Thank you for giving an excellent talk. I have two questions here. So my first question is about the design choice of using the central aggregator to relay messages. So I'm thinking about an alternative. So is it possible to organize participants into, for example, peer-to-peer networks, such as participants can directly communicate and relay messages like Tor? So this is the first question. And my second question is, if I understand it correctly, so in the system, participants have to pick up messages from the aggregator by batch. So in order to avoid any traffic pattern leakage. So I just wonder if that will affect the tail latency of communications. So that's my questions. Thank you.
Great, thank you, Tianxiang. So to answer your first question, so that isn't something that we considered in this setting. It is something that maybe could be an option, but a couple things. So first of all, it might raise additional security concerns or implementation about doing that peer-to-peer communication directly. And in our specific context, it wasn't applicable because of, I mentioned it very briefly in the presentation, but it might be hard to hear, is that in this context where people are in contact with people anonymously. So I don't actually maybe have contact with someone and then I don't actually know that I need to communicate with them because I got infected, a few days after I was in the same coffee shop as they were. So in that context, my phone is not going to be available right next to them to do the communication. But in other graph queries, it might be relevant. And so yeah, that's not something we looked into, but of course that is some architecture that could be possible. We were focused on one where truly like the participants have no ability to communicate outside of this routing to a central aggregator. In terms of the fetch, what would you say? You asked whether
I'm asking whether participants have to fetch messages from the aggregator by batch. So if you just fetch messages one by one, it may leak some information.
Yeah, so yes, you're right. This does have to happen by batch. So this this may have some effect, but I mean, in terms of how it's actually implemented, you can do it. All that matters is you kind of basically have some set time period. So what we have is we have what we call C rounds, and all that matters is that you pick up, like, say that I have 10 messages I need to pick up. I just have to pick them all up within this 1 hour period. How I actually implement that, you can do however you like. Because they're all encrypted, they all kind of look random, they all look indistinguishable. So as long as all the aggregator sees is, okay, during this C round 1, Ito picked up 10, and also during C round 1, Tianshang picked up 10 messages. That is not as worried about.
Yeah, got it. Thank you.
Cool. I think there's another audience asking question. I believe it's Gao Wei.
Hello. Yeah, thank you. Yeah, hello, and a very exciting presentation work. And I have a question. You claim that the first graph privacy work, and I believe in the future someone will try to attack your system. And my question is, can you share some opinions about future attacking future attacking method about your system? And a case maybe, if I have the idea about your graph structure, can I steal some privacy information or make your system fail? Okay, that's my question.
Okay, thanks, Gao, for your question. So first of all, if I had an attack now that I knew succeeded on the paper, then I wouldn't then we wouldn't put out the paper now. But you're right. I mean, there are basically a few vectors of attack, which are essentially the aggregator observing through traffic and also colluding with the other participants in the process. So these are things that we try to analyze, and in our paper we have things such as looking at the anonymity sets that an aggregator can reduce. So if in this mixed net, the aggregator can try to like reduce the number that it can figure out, okay, maybe here's a set of 10,000 messages, and I know that one of them comes from Ito, and what can they do to try to intersect different sets of that? So that's one thing we analyze in the paper and is a vector of attack. Of course, I mean, I welcome any potential security review and making sure that it's secure, because that's what we want. I think that in terms of what you're saying about knowing the graph, so I mean that is one thing that we try to protect is one thing that we do to cover up anything that may be leaked from knowing the graph is that we have dummy messages being sent. So everybody's always going to send the same amount of messages. So, for instance, I may only have a few friends, but I'm going to send the same number of messages just as you're going to send the same number of messages. So knowing something about the structure of the graph is not going to help me in that scenario. But I don't know, like maybe for this to be deployed, it would be interesting what kind of practical security concerns would become an issue. Trying to handle all of the different things that could come up.
Okay, thank you.
Yeah, thanks.
Right. Thank you. Okay, let me see if there's any last question on the chat or on Slack. Don't think so. I don't see any.